Hai, Assalamualaikum warahmatullahi wabarakatuh. Uh, my name is Ahmad Faiz Hakimi Muhammad Basri from Group 10. Uh, my my teammate is Shamsul Faiz, Iskandar Shah, and Chong Yuquan. Our group basically doing project is about automatic window system using rain sensor and servo motor. So for this project, our inspiration is about the unpredictable weather. The first issue is unpredictable weather. Rain can start suddenly, especially in Malaysia. Even when the weather appears clear, we cannot know when it's going to rain. So sometimes we open the window in our house, especially for airflow in the house. But the problem is when window is left open, uh, rainwater can easily enter the house. So this is second is an issue about human forgetful. People may leave the house in a hurry or simply forget to close the window before going out. Sometimes they are asleep or busy with work or do not realize when it starts raining. So, as a result, rainwater can enter the house and damage the furniture, electronic device, many things like document or other house belongings. Next. So, from our project, for our project, we use offline embedded autonomy only because we didn't get further to do about cloud depend IoT. So for this is about difference of using offline embedded and cloud dependent IoT. For the first advantage for offline embedded is a latency. It has a zero latency because has not using Wi-Fi connection or something that through to the internet. And second is a vulnerability. It is because fully contained, impenetrable to network drops. And three, for application is reliable because we can use in a rural environment, remote area. We don't have did we not use Wi-Fi connection basically for this project. Next. So we have three input. We have sensor like a rain sensor for environmental monitoring. An LPC act as a brain for this project, and output is about servo motor to open and close the window. So I will pass it to my next member to explain more.
Okay, for the next slide. On this slide, we compare the Arduino and the ARM Cortex M3 LPC 1768 microcontroller. For our automatic window system, real-time processing and accurate motor control are important. The Arduino uses an 8-bit AVR architecture, which provide the processing capability. In contrast, the LPC 1768 use a 32-bit ARM Cortex MP architecture. It offers faster processing speed, better PWM, precision for servo motor control, and greater input-output reliability. Therefore, the LPC is more suitable for this project because it can provide reliability and predictable real-time control for the automatic window operation. Next. So this is the slide explain how the rain sensor works. The rain sensor operates based on the principle of resistance detection. The sensor surface contain conducting track that have high resistance when dry. When rainwater fall on the sensor, the water breaks on the conducting track and reduce the resistance significantly. This change This change in resistance create a different voltage level that can be detected by the microcontroller. When the detect value fall below below a predefined threshold, the system recognizes that rain is present and active the window closing mechanism. Next. Okay, this diagram show the LPC 1768 communicate with the rain sensor and servo motor. So we use a pin P0.0 and pin 2.1. Pin 0.0 is configured as an input the continuously read the signal from the rain sensor. Inside the LPC, fast GPIO register are used to manage the input and output operation. The video DIR register set the pin direction FIO pin, read the sensor status and PO set or PO clear. Control the output state. So the for the pin P2.1 is configured as output and send control signal to the servo motor. When rain is detected, LPC process the data and send the appropriate signal to the servo motor, cause the window to close automatically. Okay, I pass with my friend.
Okay, as we can see here, this as we can see here, this is waveform installation. In here, it is math and timing behind controlling the window and physical position. Firstly, the servo motor calculates position based on the width of a pulse within the standard 20 millisecond period. Okay, now we continue to dry state. When dry state, it sends a 1.5 millisecond high pulse to create using exactly 80,000 delay cycle in code to hold the motor at 90 degree, which is window open. But when it wet state or it detect rain, the pulse width drop to 1.0 millisecond, which is 12,000 delay cycles to rotate the motor to 0 degree, which is the window close. Now, we to the circuit connection. As we can see here, this is the rain sensor LPC1678 and the servo motor. The rain sensor feeds into input pin 0.0. The LPC1768 process the signal using its main power line 3.3 and 3.3 or 5 volt and immediately outputs the pulse signals out of pin 2.1 to drive the servo motor. Simple, clean, and entirely self-contained. And now we continue to the software flowchart. On power up, the system hits the reset handler to set up the pin direction. It enters the continuous main loop, checking the sensor pin via TST, test instruction. If the signal is high, which is dry, it branches to the cuaca routine. If low or wet, it branches to hujan digesan. It executes a software delay loop, counter register RT down to 0 to sustain the PWM pulse perfectly before looping back indefinitely. Okay, we continue next for our friend.
So now we can do a small conclusion for this simulation. So for the dry set means ventilation. So we can see the sensor step is high resistance. This meaning it was no water, no raining. And for the code logic is TST register will be high. And for the signal, it will become 1.5 millisecond PWM generate. And for physical result, the servo hold at 90 degree of the window, 90 degree, and the window remains open for air circulation. And for the wet step protection, the sensor step will be low resistance, means reached by rain. It was raining. And for code logic, the TST register will be low. For signal, it will be low than the dry step. So it will become 1.0 millisecond PWM generate. Then the physical result, the servo motor will rotate to 0 degree. So means the window will lock, will close. Next. So now we will talk about the architecture constraint and system evolution. So in this simulation, we have some current limitation. So the first is blocking software delay. The current delay loops helps other processor operation and will limiting the multitasking. So for the second is polling-based reading. The system continuously asks the sensor for each step, which is processor intensive. And the third is signal noise. Lack of a debouncing device cause minor server jitter if sensor signal very rapidly. So when we have the current limitation, we also have the evolution roadmap to improve it. So the first is hardware timer. The shifting from software loop to dedicated hardware timer for fileless PWM precision. For second is interrupted service route times. It is ISR. It will replacing continuous polling with an even driven interrupt for better efficiency. And for the third is adaptive extraction. The programming intermediate servo angles based on the intensity of the rainfall. Next. And the final, we will talk about the reliable autonomy achieved. So what is reliable autonomy achieved? It is indicates that the system operates independently and reliably without requiring human intervention. So they have three core achievements. The first is proof integration. It is successful marriage of ARM Cortex M3 low-level resistor manipulation with persist mechanical actuation. For the second is continuous vigilance. The system operates indefinitely in a real-time loop without external input or internet connectivity. For the third is tangible benefit. The transformer a standard architecture feature into a responsive system that actively protect residential interior. So for the conclusion, by reading low-level hardware control with everyone environmental challenge, we achieve true home automation, which is invisible, reliable, and entire autonomous. Thank you. That's all.
So next, we will show you our project.
Hingga cantik.
Okay. Siapa ni?